Welcome back everyone to another episode of the Doom series, and in this video we are going to reorganize our project a bit. So if you remember, in the previous video we had the loading textures of walls and everything working correctly. So in this video I have first of all we are going to open up our main.c file, and in here I'm going to remove all of these headers, and basically we are going to remove all of the code we have already. Actually, I have already removed all of the code that we had in the last video. So all of those loading textures and all of that stuff, we are going to remove all of that code from our main file, and it's going to basically be like it was earlier. It initializes the renderer and then updates and renders the engine. So apart from that, it does nothing. So that should work quite well, and we should now be handing over all of the control to the engine. So that is the thing that we should take a look at next. However, the problem is that now that we want to render our walls with textures, what we will need to do is we'll need to basically change it so that our walls, that once we are rendering, they also have like texture coordinate information stored with them. Now we are currently using a single mesh for all of that, so it's kind of not possible that way. We could use some uniforms to do that, but that would be a terrible idea for performance and everything. So what will be a better way is to not do that, but instead generate a mesh for each of the walls as well. So we are generating the mesh for the floors, but we were not doing that for the walls, so we are going to do that for the walls as well, and everything is going to be a mesh basically. So this means that our mesh will need a lot more information. So first of all, let's take a look at that. So I'm going to open up mesh.h. In here you can see I have added two new fields. One is the texture index and the other is the texture type. So what this means is that texture index will basically represent like the index of the actual texture we need to use, and this will only be applicable in case of texture arrays, otherwise it's not applicable. And the texture type is going to be basically tell us whether we want to use the you just use a plain color from the palette, or we want to use like a 2D array texture, or we want to perhaps use just a single wall texture. So that this will tell us that. And now to pass this information, we need to run mesh.c, and in here we have added basically two new vertex arrays, and 2 and 3. This is of type glint, and one very important thing that you need to note is that you can see this I here. So earlier we were using gl vertex attrib pointer. We need to say vertex attrib I pointer, and this is very important. Without this, any integer stuff won't work, and it will try to interpret it as floating point or something, and you won't get in the shader, and this can lead to some annoying bugs. And as you can see, we need to put this I here in order to work for the integer ones. So we are basically going to pass the texture index and then the texture type here like that. And now to actually use this, we are going to go ahead and take a look at our renderer.c. First of all, let's open up renderer.h. In here I have removed the functions for setting whether we are using the texture or not, and all of that other stuff. We only have the palette texture and the draw texture setting function, and the reason I removed those is because now that information is stored in the actual vertex, and we don't need to store that in a uniform separately. And another thing is that I have removed all of the other drawing function, because now they won't really kind of work with our new stuff that we are doing here. So we need to kind of remove those, and we won't really be needing 2D rendering at all anyway, so we are going to remove that. And now let's go in our shader. You can see I have added two new inputs here. One is the texture index and one is the texture type. So here we have got these, and we just basically the vertex shader need to pass it to the fragment shader, and for that we use out integer text index and text type. However, see that we use flat here. Now this is very important, because by default OpenGL interpolates everything between the vertex and the fragment shader, and that is the way it needs to do it to make it work. However, we need to understand that integers cannot be interpolated, and we want this to not be changed but instead be passed as is. So for that we are going to use flat out here instead of just out. This tells OpenGL to just pass the data as is and not do any interpolation, and in here we just set that data. So now inside of here we have removed all of the uniforms related to use texture and everything of that sort, and in here we take our texture coordinate. Then we have got flat in here. The flat keyword is important here as well. It needs to match in both places, and we just basically take in as input we take the texture index and the texture type. Now in the main, if our texture index is -1, we just discard. Now we'll just use this to if you don't want to draw something, then we'll set its texture index to -1, and this means that the fragment shader will discard it and nothing will be displayed at that point. So now for the texture type, you can see that we check if the texture type is 0. If it's 0, then in that case we just assume that this means that it's a plain color. So we just use textual fetch with our palette, and earlier we had a uniform called color. However, right now we just, if there is no texture that we want to apply, that is the texture type is 0, then in that case we set our texture index to be used as a color. So we basically consider our texture index to be the actual index of the color in the palette. Otherwise we assume that we want to use this use sampler to the array. So for that we just set our flag color like we did earlier, get the use sampler 2D from there, and the only thing we change is that instead of having this texture index be a uniform, now it's from the actual vertex shader, and that's the only thing that has changed. And in here the other thing that I have changed is that in renderer set draw texture, we of course now don't have to set any of the stuff like setting whether we want to use texture, that boolean and stuff. We don't really need to set that, so we just bind the texture at texture1 here when we are past that. And in the init shader we now don't of course initialize those uniforms that we are not using, and apart from that the rest of the file is pretty much the same. And of course we don't actually have the other renderer draw line and all of that functions because we don't need those anymore. So let's go ahead and now let's go actually open up engine.c, and here is the main stuff that we are doing. Now you can see that I have removed the wall node and the wall list types from this file because we are not going to be using this. And the flat node, I'm gonna just rename this to draw node because now it represents anything that's supposed to be drawn, and it's gonna have a mesh, a sector, and the actual draw node, that the next draw node that we need to draw. So after that, let's go here and go under our engine initialization function. And by the way, one more thing that you need to note is that now we generate the wall textures here as well, and we have got the number of wall textures as well. So in here what we do is basically we generate the wall texture basically just like we were doing in our main.c file earlier, and after doing that we call generate meshes. Now the one important thing we need to make sure is that we call generate meshes in the end after we have done all of our flats and stuff, because generate meshes will validate the textures, and if we have not loaded them, then of course they will be incorrect. So we need to make sure that our generate meshes is valid, so for that we need to do that in the end. Now let's go under generate meshes. And by the way, another thing is that in engine render you can see that we just need to go over each of the node and draw it with an identity matrix, and we don't need to do anything else. We do need to set the draw texture to flat texture array, and apart from that we don't need to do any other tests or any other transformations or whatever. We can just pass this directly. Now for the actual generate meshes and stuff here, you can see that this is a long function. So let's go ahead and examine it step by step. First of all, I'm going to actually remove this model from vertices because we are not using that anymore. We are going to just generate the mesh directly. So let's go here and let's start. So the thing that I've changed is that in generate meshes, this is basically the same stuff apart from the fact that the name of draw node has been changed, and the floor generation is pretty similar. The only thing I have changed is that now we have got two nodes. So earlier we only had a floor node, now we have got a floor node which we generate. Then we have got a ceiling node as well, because now we are just drawing all of the draw list as is. We need to have the floor node and the ceiling node separately. So in here we set the sector and stuff here just like we were earlier, except the fact sector is now a local variable because that would be better, so I did it that way. And now when we are setting our vertices, now we've got actually two vertex arrays. So earlier we only had vertices, now we have got separate vertices for floor and ceiling. Now initially when we are generating this stuff, what we do is we just to set our floor vertices equal to our ceiling vertices, which means that we leave the y at 0 and we don't we set the texture type to 1. However, we don't set the texture index. The reason is that on the first vertex we might not find out what our sector is. So only after our sector is not null, which means we have gone through all of the vertices and find out what the sector is, only then we can assign the correct textures and stuff. So here we just you can see just go over all of this and we set the floor textures are equal to the ceiling texture. But after we have generating that stuff, we again loop over all of the vertices and we set our we basically get a floor texture here and the ceiling texture, and then we set the stuff on the floor vertices and the ceiling vertices is the stuff that's supposed to be different here correctly. So for the floor vertices, you can see we set its y position to sector floor, so we get the sector's floor level divided by scale, and we set the y position to that. And similarly for the ceiling, we set the y position equal to the ceiling divided by scale. For the texture index, we first validate that our texture is in range. If it is in range, we set it to the floor texture, and otherwise we set it to -1, which means it won't be rendered. And we do basically the same thing for the ceiling texture. So basically, if anything has invalid texture, it won't be rendered. Now this triangulation stuff is pretty similar, and the only thing that's changed here is that now we generate two meshes, one for the floor and one for the ceiling. And of course we need to make sure we set the floor sector and the ceiling sector equal to the local variable sector that we have got. And when we are freeing, we need to free both the floor and the ceiling vertices to avoid any memory leaks and stuff. So now let's get into the walls. Now for all of the walls, all of them are going to be quads, so the indices is going to be same. So I just declared it earlier. It's going to have like 0, 1, 3 and 1, 2, 3, basically a quad. So we're going to have 6 indices. However, the vertices are going to be different, so we're going to get those separately. So in here you can see that earlier on the stuff is pretty similar, except the fact that we use draw node here. And after we have done generating all of our floor vertices, what we do is we actually scale them right here. So we just scale these by 1 by our scale, in order to get them correctly within our view space. And after that we use srand and random function to get a color based on our sector. So we basically do this so that currently we are not applying texture right now, so just to make sure everything is working, we are going to do this like we were doing earlier, except the fact that now this is going to be a part of the vertex data instead of a uniform. So then we generate an array of floor vertices, and for the position we just set it to floor 0, floor 1, floor 2 and floor 3. For the texture index, which we use as the color, we are going to set it to our color, and the texture type is going to be 0, which means it's going to be a plain color. And instead of setting the model matrix, because we don't have that anymore, we generate a mesh based on the vertices that we have generated and the indices that we had earlier, and we set its sector here correctly. Now basically the same thing goes for the ceiling node. We generate the vertices, we scale them, then we get all of the other vertex data here correctly, and then we call mesh create. And that is basically all we do. So that should generate these correctly, the line defs that are actually two-sided. So this is going to generate the two-sided line defs correctly. Now for the one-sided line defs, it's going to be of course even similar, and it's except the fact that instead of doing separately for floor and ceiling, we are going to do it only once. So in here you can see we have got our P0 to P3 vertices, and here we just scale them, then we get a random color, and then we generate some vertices based on those and set the texture type to 0 and the texture index to the color, and then we just create the mesh. And that's pretty simple. So that's all of the stuff we need to do in order to get this to render correctly. So now if I go ahead and run make, you can see that we can get all of our stuff here correctly, and the ceiling and the floor textures work. Of course our wall textures are not currently applied, but now we are in a position to start applying the wall textures when we want to. So yeah guys, this is gonna be pretty much it for this video. In the next video we are going to use this framework that we have created to actually add the wall textures, and I'll see you in the next one. And another concern that you might have is that this way we are wasting a bunch of memory for the walls. Well, that doesn't really matter, because we don't actually have like a billion walls, because we only have a few ones, and currently this program is like only using 4 megabytes of GPU memory. So for a Doom map, that memory concern isn't really real. So anyway, I'll see you in the next one, in which we'll start adding the actual wall textures to the actual walls. So I'll see you in the next one. Make sure to like and subscribe and share this video with other people as well, and bye.